Hello everyone, I am Arifin Imroz, and today we are going to discuss about Linux LVM, the logical volumes. Let's know that what is LVM and why do we need it. LVM is nothing but a dynamic partition where we will be able to create, resize and remove partitions without any system reboot. The logical volumes can be resized dynamically as space requirements change and migrated between physical devices within a pool on a running system. Few terms that we should know: that PV is for physical volume, and physical volume will be seen as dev, SDA1, SDA2, SDA3. And VZ are the volume groups where the physical volumes will be pooled, and LV is the logical volume. These are seen as a storage facility to the operating system. In the picture here we can see that there are 4 physical volumes. Those are PV1, PV2, PV3 and PV4, which are under the volume group VZ. There are 5 logical volumes that are LV1, LV2, LV3, LV4 and LV5. And under the logical volume there are separate directories as per requirements. First of all, we are going to use the command fdisk-l that will show the partitions you can see. Now we are going to create a new partition, and that will be extended partition. Here you can see that we used fdisk, and this is star. This star indicates the root partition, and here you can see the swap partition, the SDA3, and these are the starting and the ending points of the partitions, and the block sizes are there too. We can use another command lsblk that will show the partitions more specifically. It will give you a good idea about the partitioning system. Here you can see the SDA is the main hard disk, 60 GB, and SD1, 2, 3 are the other hard disks, and 60 GB here you can see. Now let's make a partition, and that will be a extend partition. Here M is for help, and here you can see for creating new partition N, and there are the partition types, primary for P and E for extend, and we are going to create a extend partition. Default is E, so if we press enter then it will select automatically the extend partitioning system. Here after pressing E, so we are taking not specifying any size, we are taking the full size, pressing enter, and now you can see that the 48.5 is set, the extended partition. Here by pressing P you can print the partition table. Here you can see that we have just created a partition, that is extended partition, and now we are creating another partition by pressing N. The partition is number 5, and we are again starting from the beginning, and that's why we are pressing enter, and then we are specifying a size of the partition. So we will use plus, and we are keeping a size of 250. Here pressing P we can see the partition, and now we will choose the partition type. by pressing T, and the partition is default 5 that we just created. Now pressing the L for the list of the partitioning systems. Here are the hexa codes, and we will use the 8E code for Linux LVM. Here we are using 8E. Now we will print again, and here you can see it is just to Linux LVM from Linux. Now we will save the work by pressing W. Here you can see the partition table has been alerted. That means it is created. Now we will create 2 more partitions under the extended partition following the same system. Here we are specifying a size of 550 MB. Here you can see that 550 MB is set. Specifying the type using T and again L, and then using the code 8E for Linux LVM, and it is done. You can see by P print. Here you can see that the SDS6 is done, and then another we are going to create by N, and we are again specifying a size of 100 MB, and 100 MB is set, and we are going to change the type from Linux to Linux LVM by T, and we want to see the list by L. We are entering because we want this 7. Here is the 8E Linux to Linux LVM, and we want to set the work W, and it is done. We are using the important command partprobe and selecting the hard disk, entire hard disk, and now it will save the whole work. Here you can see everything is showing, all the partitions that we created just now. Now we will see how to create the physical volume. Here we are using the pvcreate command and selecting the partition that we just created and successfully created, and then SDS6, enter, successfully created, and the last is 7, it is successfully created. So we have created the physical volume. Now we will see by PV display. Here you can see all the physical volumes are here with the size. First one was 550, last one was 100, and the second one was 250 MB. Here is a command that is vcreate, and we are creating a volume group named vc1, and we are specifying the partitions, the SDA5, SDA6 and SDA7. We are mentioning all these under the vc1 group, and here you can see the volume group vc1 successfully created. Now you can see the vc display here, all are under this vc1 group. So the size is 892 MB. If you summation all the partitions size, then we will get this. Now we will learn how to create the logical volumes. We are using the LVcreate. We are specifying the name by -n. We are specifying the name LV1, and we are specifying the size, and we are specifying the, and it is 400 MB under the VZ1 volume group. It is very important to mention it there. Here the logical volume LV1 is created. Now we can see it by LV display. Size is 400. And now we are specifying it to XFS, and we are showing the partition path, and it is formatted to XFS. Now we will make a directory for mounting. We are making a directory named LV data, and we will mount the partition system under the LV data. Here we are putting the path, and here is the LV data. We are pressing enter, and it is done. Here you can see the mount point LV data and the partition that we just created under the VZ1. The LV1 partition is showing there, the logical volume partition here. Here is an important thing to understand, that we created a logical volume of 400, and here is an interesting thing, that it is not under the SDF5, not even the SDF7, because the size limit is over 250 and over 100. It only sets under the 550, so it is automatically taking the 550 SDF6 and it is going there. Now we will check another issue, that we will create another partition of 220, and let's see what will that go. We know that it will go under SDF5 since it is 250. Let's check. Here we are creating another logical volume, and that is a size of 220, and we are specifying the name is LV2, and it is under the VZ1. The LV2 is created here, you can see, and let's see LV display. Here you can see the size is 220. First one was 400, the LV1, and second one is 220. Now change the file system format. We are changing it to XFS, and we are specifying the partition VZ1 LV2, and we are entering. Now we will create a directory named LV2 data, and we will mount the LV2 logical volume under this directory we have just created, and now we'll mount it, and we are specifying the partition and LV2 data. Enter, and it is mounted. Now if you want to see is it mounted or not, here you can see all are mounted. Now here you can see that it is mounted, the mount points are showing there, and LV2 has gone under the SDF5 that we wanted to check, and it is proved. Now we need to do another important thing, that we haven't yet mount the partitions permanently, so we have to enter into the etcfs tab file, and there we need to edit some things. Now we will just edit these two lines here, the LV1 and LV2. The partitions are mounted under LV data and LV2 data. The file system is XFS and defaults 0 and 0. that's it, and we'll save it and we'll mount it by mount -a. Now we will reboot and we'll see that is it exist or not. After rebooting, we have been turned into the system, and now let's check by lsblk. Here you can see that all are there, so all is okay.